Hi there, welcome back to the channel. Welcome to the start of a new tube radio restoration project. And this one is different. This one came like this. There was no cabinet, no wood involved. This thing came exactly as you see it, well, with the exception of these brackets that I put on. I bought this at auction together with another one. This thing interested me particularly because it looked like all the parts were there. And what really prompted me to get this is because this is a Siemens. It's a Siemens Super G7. Now, you may have heard me say before that I'm particularly fond of Siemens. They were the first company that I worked for in South Africa when I finished university. So I know that the quality is going to be there. These guys were meticulous in their design and in their builds. And so I don't expect this to be completely different to the other radios that I've restored in terms of the way it's set up, the way it's configured in terms of schematic. But in terms of quality, I expect this thing to be good. Now, if I can get this thing to work the way it's supposed to work, it's going to be a hell of a performer. Now, there's a problem. I don't have a cabinet for it. I've been thinking of things like leaving it open with an acrylic cover on top or something like that. I'm not sure that that's going to work, but we'll figure out as we go along. When I started, I didn't even know if this was going to turn on. Obviously, I'm filming this intro at the end of this episode, so I know exactly what's happened. I know exactly what's happening and not happening. But if you want to find out, you're going to stick around and watch the video. Hope you enjoy it. But before I carry on, I want to thank the sponsors of this video, PCBWay. You'll find them at PCBWay.com, and they're the people I go to for all the PCBs that I use in my projects. But of course, they don't just do PCBs, they also do 3D printing, which I've used before to great success. They do CNC machining, sheet metal fabrication, injection molding, and a host of other services that'll take your project right from the beginning all the way to a fully assembled project if that's what you desire. If you look at the list of products and capabilities, they've got a huge array of services. I'm sure you'll find something for your needs. This is not really a conventional start to a project because normally you'd see the radio in its cabinet and I would talk about the cabinet condition and I would show you the radio details and everything else. This one is like this because this is exactly how I bought it. In fact, I bought two chassis like this, and this one is supposed to be, according to the description, a Siemens Grossuper G7. And in fact, from the schematics that I've obtained, it seems to be correct. But it's in pretty bad shape. In fact, the first problem is that it's got no speakers, it's got no cabinet, and obviously somebody probably used the speakers for a full range speaker system or something like that and decided they didn't want this at all. But of course, somebody's junk is somebody else's treasure, and in this case, I'm the treasure hunter. It looks pretty messed up. There isn't anything wrong with this part of it. The faceplate, or the dial glass, the knobs, the piano keys, everything's in place. In fact, it's actually all in pretty good condition. Even the indicator here for the tone is working, or it's wired up. We've got a volume control here, and we've got a this is an antenna rotation selector, so you can actually move the antenna around, the ferrite antenna. And if you listen at the end, click. Normally that switches off the ferrite antenna and connects it to the antenna port at the back, which is what I prefer to use. But this one actually gives me an idea because I think I'll be able to use this for the shortwave fine tuning that I've just worked on recently. That's what I mentioned when I talked about antenna direction indicator to use as a shortwave fine tuning. So that's all fine and good. The piano keys all seem to be working. I don't know what the contacts are like inside. These are the pre-select tone settings. In fact, you can see here SPR is, what is that, Spreker or Sprache, speech. A bar. Hell, I don't know what that means. Baritone? I don't know. And orchestra. Okay, so those seem to be okay. They're clicking in place at least. And on this side, we've got the treble control. And again, the indicator seems to be working. It works in reverse to the other one, but I suppose that's on purpose. And here we've got tuning. And again, it's a single. How does this work? This is strange. Is it stuck? You see, what's happening is that this thing is moving both tuning condensers. That is the FM front end, and that's the tuning on the FM front end. That is the AM band tuning condenser. When I move this, both of them move. And in fact, this is rather odd. I think they should be separate. I think this thing is stuck inside there. Usually it gears it in place. And I'll tell you why I think it's stuck. I don't know if you can see that, but if it was one tuning that tunes both, these two indicators should be one. This is actually, it seems to be a separate pointer for the FM to the AM bands. Mind you, it could be shifted apart on purpose. I don't know. I'll only be able to tell when I open this up. But as I said, there's nothing broken, there's nothing chipped, none of the paint has fallen off. So this thing is perfectly recoverable. And whether they're geared correctly or not, we know that both tuning condensers are working. So that's a good start. You see, here is the ferrite antenna, which does indeed rotate, but all this cord has been removed and just stuck up here. So obviously this thing is broken off from that knob there that changes its direction. We'll have to see how that works. But it seems to be in place. We've got these trimmers on here as well. Yeah, there's a switch down there. You see, when you go round, there is a switch down there. And if you go all the way around, I don't think that switch is making contact at all, but it obviously switches something there. My guess is that it's at the end. Remember, it clicks when it goes to the far right, clockwise. I think that at the end it clicks off so that your antenna connection is switched from the ferrite to the antenna socket at the back. Well, this rubber is broken. They put a zip tie on here to hold the ferrite in place. The rubber bands that they have there obviously dried out. It's got all these, what are these, polystyrene capacitors? These are normally pretty good. There is a paper cap down there which needs to be replaced. And here's the socket for the magic guide tube with the resistor at the back. And this obviously went on the cabinet itself because there's nothing on the chassis where this connects to. So I'm going to have to insulate this, make sure that it is safe to just leave hanging here. I don't want any shorts. This is the output transformer, and this is where the speaker connectors are. Now there are two wires over here, which somebody obviously snipped, and there's one more coming off here through a coil and just hanging in thin air. I think this might have been for some sort of tweeter. We'll find out when we look at the schematic. The output tube is an EL84, pretty common on these radios. The detector and preamp tube is an EABC 80. There's the usual IF amplifier, EF89. I believe this is an EF80, which is not as common as some of the other ones on these radios. ECH81 as the mix oscillator, again very, very common on these. And just to complete the tube lineup, we've got an ECC85 over here on the FM front end block. Power transformer over here, pretty big. And the usual filter can with, 2 or 3 capacitors. This is 2 capacitors, 50 microfarad each. The voltage selector is quite interesting. It's not a rotating thing. It's actually a sort of tube socket. And they've wired the different pins over here. So what you do is you choose the one you want. In this case, it's set for 220. And you plug it in like that. If you wanted 110, I suppose, you plug it in like that. Just wondering. Oh, not all these have got pins. That's why it will allow you to plug it in like that, like that, like that. I'll leave it at 220 for now. I'll probably put it to 250 later on. There's the antenna sockets for the FM dipole. Those two there will be ground, and antenna for the AM. This is probably phono input. Now this has got a center connector as well. I'll have to check the schematic and see what that's about. That over there, I believe, will be the speaker out. I'm not sure why there are 3 terminals. I'll have to check. This is probably a tape in or tape out with this DIN socket. And what I like most about these radios is the type of IF transformers they've got. For a start, this thing's got tape over it. Let me remove the tape. Yeah, it'll come out finally. They put just clear tape over it once they've adjusted it, just to prevent anybody from being tempted, you know, to play around with the screwdriver. And then you've got the IF transformers over here. So it means that your both your FM IF and your AM IF are actually adjusted from the back. You don't have to go on the underside. This is a great system. Much better than the ones we have to do the top and bottom. Actually, having just said that, I do see this here. So maybe this is for the AM and the FM is through the top. I'm not sure. But I do like the system at the back. I find it strange that they've actually got a core in there. And it does have wax in it, so it is adjustable. And it probably does have something on the underside. So everything I've been saying about how great these are is probably not as great as I thought. Really messed up top of the tuning condenser there. It almost looks like pigeons have been at it. Anyway, I'm not afraid of cleaning. That's not a problem. I'm going to put this on the two brackets that I use so we can get a look on the underside, because I'm really keen to get started on this. I'm not sure really what my goal is. I mean, I want to get it to work. I'm not sure what I want to do with this. Maybe I'll use it as an experimental radio like I did for the Grundig that I showed you in the fine-tuning, shortwave fine-tuning video. I know this thing will work very well. The quality will be excellent. I mean, it is a Siemens, but I really don't know what I'm going to do with this without a cabinet. And I don't think I want a cabinet. I wasn't particularly aiming at adding another radio to my collection right now. I'm wondering whether this thing just needs an acrylic case on the top and leave everything on display. Hey, a topless radio. Why not? Well, it seems that someone likes red and yellow. Probably the colors of their favorite football team, because this thing is full of red components. And I believe they're all resistors. All the resistors are red. Now, these resistors tend to be good until they're not. I normally test 3 or 4. If I find 1 or 2 that's off, that means that I've got to check them all. If I find them all within spec, it means the rest will be all in spec. So, yeah, okay, there's one big bugger there. There's nothing obviously damaged in here. And all the wiring, this is great. This wiring is actually shielded. If we take a closer look at this wire, you'll see that it's got a shield on the outside and then the wire on the inside. It means that all the wiring they've done here has got a protective shield. Now, in most cases, you would simply have 2 wires going there, separate. So this thing is probably very silent, at least for pickup of noise. Actually, you know, what I'm going to say is sacrilegious, but when someone broke up this radio to steal the speakers, they probably would have done better to steal the wire, because this wire is very useful when you want to wire things inside a tube amp or even just any kind of audio equipment. This wire is great, and I haven't found, I'm sure they sell it, but I just haven't been able to find any in Madeira that would be as good as this one. But I'm not going to rip it apart. I will not rip it apart. I will not rip it apart. Something else I've noticed, there are capacitors underneath here. You can see that there. There's a resistor. There's another one somewhere here that I saw. And these guys are not accessible from the top end. So I may have to remove this whole assembly, meaning this entire assembly, to be able to get to the underside. I hope not, because there are a lot of wires connecting to it, and I do not fancy my chances of desoldering everything and getting it all right again. I mean, you can do that, but it is a pain, a real pain. Then again, I might have no choice, because there are components on the underside there, and I'm not sure how I'm going to get to them without lifting this up. We'll just have to wait and see. First thing I want to do is to check where these wires go to. All these wires are loose here. This is obviously the speaker, but I did check anyway, because if I put the multimeter on there and I check it to ground, it's about 1.5 ohms, which what we're measuring here is the DC resistance of the secondary winding, which makes sense. And I've got that on the schematic as well. And obviously the part I'm looking at is over here. And we know that there are 2 wires going to the speaker. One of them is connected to ground, which is fine. Okay, now what about the other 2? There is this inductor over here, which I had a bit of a problem figuring out what it was. But again, you see here it shows this inductor, and it comes down through two sets of switches, and I couldn't figure out exactly what this meant, what the switching system meant, and then I realized it makes sense. What they've done is they've got the speech button here, the bar, and as I said baritone. It's obviously not baritone, probably bass or something, and orchestras over here. And these things indicate the switches on this row. You see that? There's one there, one there. These are activated when you select orchestra. These two here, that one, are activated when you select bar. And this one, and this one are activated when you select speech. It actually does make sense. So when I look at this inductor, this one over here, it comes down in the off position. It goes through there to a 25 microfarad capacitor, electrolytic. When I select, I think this means that speech is selected as it is here. So this is in the rest position. So when I select bar, these flip over. When I select orchestra, that one flips over and that one flips over. So what we're seeing here is when we leave it in the off position, the bar in the off position, this signal, if I measure the resistance from, say, here, down here, down there, down there, down there, to this electrolytic capacitor, I should get 0 ohms, or close enough. And I can actually do that. I know that the particular capacitor in question is the one in here. It's one of those Siemens capacitors. And if I put this over there, if I select speech, which is selected at the moment, the other two are off. Let me select baritone. That comes on. Let me select orchestra. That stays on with a few ohms, but that's just lead resistance and that sort of thing. If I select speech, it goes off. So that there obviously goes up here, and it goes to two speakers. Now, this would seem to be, yeah, there's a 25 microfarad capacitor here. So these are tweeters, high frequency, but they are audio speakers. They are not electrostatic tweeters, because the signal here is not at a high voltage. It's literally an audio signal reference to ground, because this capacitor will block any DC. So we know that if we want to put two high frequency speakers on here, we use the lead that comes out of that coil, that inductor. Now, what about this guy over here? Well, I've actually trimmed that back, and this is obviously ground, it's the shield, and I'm going to connect that over there. And let's see what we need to select, or where we need to measure to see if that is correct. If we go back to schematic, we see that there are these two things over here. And I know it looks a bit weird, but these are two electrostatic tweeters. Because if I follow this through, they come in when I choose orchestra, and they go to the grid voltage, the screen grid voltage, which is a high voltage, through a 20k resistor. So this is the biasing, or the static biasing, high voltage of the electrostatic tweeter, reference to ground. We can see that. And the signal that they will reproduce, the audio signal, will come from the output of the EL84 through a 1 nanofarad capacitor. So to check that this is correct, I'm going to measure the resistance between this point, okay, on that little wire, and I'm going to measure to pin 9, which is the screen grid of the EL84, and see what happens when I select various positions on there. So let's see. I've got, let's call that infinite. That's on speech. That is on bar. And that is on orchestra. 20k. Brilliant. 20k is exactly what we expect to measure. If you take this point over here, go back, when you switch it on by activating orchestra, it comes down here, and between there and pin 9 of the L84, you now have 20k, which is exactly what we've discovered. And indeed, because this wire is wired like this, you can see that means that it's inside a shield. In fact, all these wires, that have got those dotted lines on the side are the shielded wires. And this is, as I said, the first time I've seen a radio with so many shielded connections. It's a brilliant idea. It makes for very clean audio, but we now know what these wires are. And we also know that this one we've got to be careful with, because this thing will have high voltage. This will have voltage from the screen grid, so I'm going to insulate that before I do anything stupid to myself, or before it touches the chassis and shorts something out. I'll just do this, just for safety's sake. Do I need to say it? These things have high voltages. They can kill you. If you're working on this, you're doing so at your own risk, blah, 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 blah. This is a blah, blah, but it's very, very important. This one here is not that important. This is audio, because it does have that capacitor there that prevents it from getting high voltage through. You could still insulate that. Probably a good idea, because I'm not going to connect speakers to that just yet. I may do later on. So I'll just do this to it. Why not? Keep it from shorting to ground. Makes it safe. The only two we're going to use are these two, which means I don't need to worry about this guy. This guy I'm going to tape to the bracket so it doesn't hang around too much. That way I know that it is safe. Now I'll just put these guys on here, ready to receive or to connect to a speaker, and they're also sort of insulated and they don't flap around. Okay, that mystery's solved. So here we are. We've made all the loose wires stick in place, or at least we know what they're doing. There's no loose wiring flying around. The magic eye has also been taped to the edge here because it was flying around as well. And that is very dangerous because there is B+ on there. And if it touched the chassis, we would have some fireworks. So what have I done next? Well, I've done two things, which is what I normally do when I start these restorations. I have checked the power transformer to make sure that it's fine, and I've done that without powering it up. Now, I do show how it's done in a video that I've done before. I'll link that below, and I've also shown it in the Back to Basics series, which I'll also link below, so you can look at that if you want. I've also checked that the output transformer is fine, and again, that's done without applying power. It's just using a signal generator to make sure that we get some sound out of the speaker when we feed a small signal into the anode or the plate of the power tube, and it goes through the output transformer. Again, I'll link that below. So I know that the two of the main components here are working fine, the power transformer and the output transformer. Not an absolute, we believe it's working fine. The only way to really find out is if we power this up, and that's what I'm going to do. That's what I want to do. Now, there is one component here that's usually advisable to change, and that is the capacitor that connects the signal from the preamp tube to the grid of the power tube. If that thing is leaking, you can get the power tube sort of running away with itself, passing too much current, and it can actually damage your output transformer. So before powering it up, I'm just going to check that, probably just tack a new one in and make sure we don't have any fireworks, because I do not want fireworks. As I said, this radio is sort of an experimental radio. I don't know what I'm going to do with it yet, but I do want to restore it as if it was in a fantastic wooden cabinet, which it isn't. It might end up in a fantastic acrylic cabinet. I haven't actually decided, but let me show you what component I'm talking about. This is the capacitor that I'm talking about. In fact, there are two of them that separate the grid. There's the grid of the power tube through a 1K resistor. Then there's 2.5 nanofarads. Then there's 25 nanofarads. So there we won't have DC from this side going through. If you follow that path, and if you come to here, you get to the plate or the anode of the EABC80 triode, which is high voltage. So high voltage over here will try to get through, but it can't get through that capacitor, and it can't get through that capacitor. So this here, with a resistor to ground, where is it? Here it is. There's a 500K to ground, and then there's a 50K to ground. This, I believe, would probably be the treble or the bass, but we'll check that later. The point is that if we check this, and if it's not leaking DC, this tube should not run away with itself. If there is DC coming through, then this will create a DC voltage over here, and it should actually be at 0 volts because we want the cathode to be at a higher voltage than the grid to sort of switch off or close the tap on this tube, and therefore control the current that flows through it. And of course the current that flows through it comes from here through the output transformer from the supply. So if this thing is wide open because we've got a high voltage there, higher than the cathode, this thing opens wide, lets all sorts of current come through there, and it can damage both the tube and the output transformer. So what I'm going to do is I'm just going to locate this capacitor and I think I'll probably just clip it out and just tack one in for now, because I'm really keen to find out if this thing works. And I'm looking for a resistor from pin 2 of the EL84 to where it meets another resistor, this one here. It'll meet this wire going up here. It's having some sort of effect on the tone, probably cancelling out the bass control or something like that. Or is this the bass? No, I think it's probably the treble. Never mind. I'm looking for this component. Okay. And if you go back to here, this is the underside and this is the EL84 base. And I'm looking for pin 2. So there's 1. There's the gap. Then there is pin 1. There's pin 2. Yeah, there's a resistor there. In fact, here it says 1.5K, whereas on the schematic it says 1K. And there's a capacitor, and it's this capacitor over here, which is 2.5 nanofarads. That's exactly it. So I'm just going to tack one in. I think I'll probably just do this. Let's see, what's the easiest way to do it? I'm going to clip it there. Okay, and I'm going to tack one in between that point and that point. 2.5 nanofarads. And there we are. I have stripped this off and it's just flying in the wind here, but it is not going to touch anything. And I've got this 2.2 nanofarad capacitor just lightly tacked into there and there, replacing that guy. I think I'm confident enough now to just power it up so there is no leaking going to the power tube. Let's turn around and get this ready. All right, first things first, let's connect the speaker up. I'm going to leave all these off and I'm going to set it to, what should I set it to? Medium wave. It's probably likely to make the most noise. Put the volume up. And now I'm going to switch all these bulbs off. Just leave the one on. I've got it on limit. And I'm going to hit it. Because medium wave is already selected, if all's working, it should light up. And indeed it does. And it's doing what it's supposed to do, which is that it's coming down in brightness, meaning that the capacitor's charged up, so you get a spike in current, and then it goes down again to 110 milliamps. And then as the tubes start to conduct, there we go, it's starting to go up in current, so the light lights up some more. And I've got some noise. Okay, we've got something coming through. What does this tell us? Well, it tells us that the preamp is working, it tells us that the amplifier is working, or you wouldn't get any sound at all. These guys seem to be having an effect. This one definitely has an effect. I can't tell. That has an effect. Let's leave this as neutral. So medium wave. It's making the right noises. And it's receiving our local station. That's about the only one that I expect to get on medium wave here with the ferrite antenna. Let me rotate the ferrite. Don't want to touch that because it does affect it. Let's see what happens when I rotate it. Makes quite a difference. Hey? Oh yeah, that's a switch. That is the effect of that switch on there when I get to a certain position. Remember, if that had been working, that's what happens when you get to the end. Of course, because that is not connected, the cord has broken or being ripped off. I'm doing it manually. So there we've got ferrite. There we've got, well, we're expecting the external antenna. Let me put the mini whip in, switch on the mini whip and connect it to the AM. See if our luck, brilliant. Luck keeps holding. There's the station. Does it get anything else? Oh, very weak. Very, very weak. I've got the volume on max. Mind you, I do have the dim bulb really restricted. So this thing's only seeing about 165 volts. If I give it another 60 watt bulb, actually I'm going to give it another one because I know we've got no shorts. That's a bit better. It's picking up Canary Islands, not picking up too well, but it is picking it up. Normally, well, I expect to be able to get it much better than this. The point is, amp's working, medium wave's working. What about long wave? Getting something there. Very weak. I can just hear it. Yeah, not much. Shortwave. Ooh. Ah, will you listen to that? That is up at the 16 meter band or so. Okay, they're all working. They're all working. Let me try FM. And let me change the antenna at the back to the FM dipole. And see what we get now. Do we get anything? Ah, it's picking up something. Ooh, it's a bit not very clear. Oh, that one is.
Para a necessidade de normalização dos sensores no circuito de abastecimento e também para maior controlo dos mecanismos da prescrição por parte das autoridades. A OJE no Infarmed também confirma
que if I disable those, it seems that those work best.
Da procura e recorda que a quando da celebração do acordo entre a autoridade do medicamento e a empresa, ainda em 2017,
Orchestra. I should get something else around here and I'm not. Let me not push my luck. So what have we got here? Well, we've got a radio that was probably going into the junk that is actually proving to be quite promising. This thing is going to work pretty well. It's already picking up on all bands. It's not that sensitive, but then nothing has been done except that one coupling cap has been replaced. All the other capacitors are still virgin. They're going to be replaced. The filter capacitor is going to be replaced. Selenium rectifier, I'll check the voltages, all that stuff. I'll do that sequentially. And then, of course, I've got to clean it up as well. But the point is, this thing was probably going into the garbage. I mean, this thing is a Siemens. Now, Siemens didn't do things cheaply. And you can see that from the shielding they put in there. Everything has been carefully laid out. And a lot of care has gone into this. So a lot of cost probably went into this. So whoever bought this in its day probably paid a pretty penny. I know Siemens is not cheap because that's the first company I worked for when I left university. And I remember the cost of their products was, it was rather at the top end. And I believe it still is today. So I expect this thing to turn out to be quite a performer. And so now I've got my work cut out for me, and I'm going to leave you now because, as I said, there's a lot to do. But I do hope you've enjoyed that. And if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, please do so on Patreon and PayPal. Links are in the description below. So once again, thanks for watching. Bye for now. And most of all, stay sane.